All right, now question 5, we are going to be describing these 3 hypothetical strain stress curves. We are going to assume that the deformation in case 1 is by Coulomb failure, and the deformation beyond the yield stresses in case 2 and 3 is governed by plastic mechanisms. In all cases, the confining pressure is 1 kilobar, so constant pressure, and we're going to have changing temperatures. So for case 1, we're going to describe the deformation mechanisms in each case. We're going to include in your account a description of what happens at the atomic or molecular level. So in case 1, we are at a low temperature, high stress situation. So low temp, high stress situation. Based on our Coulomb failure curve, this is the elastic deformation phase. Basically saying that the atomic bonds are being stretched, but not broken. So when you remove the stress, it returns to its normal position, to the original shape. And then complete failure occurs at the 200 megapascals. So that is the situation for case 1. Case 2, we have higher temperatures. So higher temperatures, and we have more of a constant strain rate. And we're transitioning from our elastic to plastic deformation. So from about 0 to say 150 megapascals, it's still elastic. Between say 150 to maybe 175, we're going through our yield stress. And then from 175 to 200 megapascals, this is our plastic deformation. This is where some atomic bonds are being broken. Others are stretched. But when you remove the pressure, right, there is permanent deformation going on. So that is our plastic deformation. And ultimately, our complete failure is again 200 megapascals, but we also introduce our 8% strain. So that is the case 2. And then case 3 is very high temps. And we're increasing strain. There's a short elastic phase between about 0 to 75 megapascals. And then it transitions to, there's a small yield stress, and then basically from 2 to 8% strain, you have your plastic deformation. And you can interpret it at failing at about 75 megapascals and 8% strain. And again, this plastic deformation, you're breaking some bonds but not all of them. So you can behave almost like a fluid, almost, not, I mean, I wouldn't write that, but somebody wrote that, can behave like a fluid, but it's flowing, right? Plastic deformation, you're breaking some bonds. When you release the pressure, you're still going to have permanent deformation. So that's the case in these guys for question 5.